This lesson 7.6 is about the change of state of water. If you are new to this channel, please do not forget to subscribe, hit the bell, and do some comments. I post educational videos at least twice a week. So, let's get started. In lesson 7.6, we have the following goals: to define matter, identify the states of matter, and to explain the anomalous expansion of water. Goal number 2, to find the total amount of heat needed to change water from a given initial temperature to a final temperature. What is matter? Matter is anything that occupies space and has mass. Mass is a measure of the amount of material the object contains, and volume is a measure of the space occupied by the object. Everything is made of matter. What are the three states of matter? We have solid, liquid, and gas. Depending on the pressure and temperature, a solid can become a liquid by melting. The liquid can become a gas by evaporation. The gas can be turned back into liquid by condensation, and the liquid can be brought back into a solid by freezing. Changes of state of matter. When a substance changes from one state or phase of matter to another, we say that it has undergone a change of state, or we say that it has undergone a change of phase. These changes of phase always occur with a change of heat. Heat, which is energy, either comes into the material during a change of phase, or heat comes out of the material during this change. However, although the heat content of the material changes, the temperature does not. The anomalous expansion of water. Water is the essential component of any living form on Earth. Therefore, it becomes important to study the nature of water for any study of life and organisms. Water is a special molecule that has some peculiar and unique phenomena linked to it. One such unusual phenomenon is the anomalous thermal expansion of water in the temperature range of 0 degrees Celsius to 4 degrees Celsius. What is anomalous expansion of water? Most liquids expand upon heating and contract upon cooling. Water between a specific temperature range seems to break this notion. The anomalous expansion of water is the increase in the volume of water when cooled from 4 degrees Celsius to 0 degrees Celsius, or 39.2 degrees Fahrenheit to 32 degrees Fahrenheit, as shown in Figure B. In Figure A, the density of water increases from 0 degrees Celsius to a maximum at a temperature of 4 degrees Celsius. Its value is 0.9998395 gram per cubic centimeter, or approximately 1 gram per cubic centimeter. Reason for the anomalous expansion of water. Ice has an open crystal structure which has a lot of space. Ice is less dense than water. When ice melts at 0 degrees Celsius, the water molecules lose this open structure and are more hydrogen bonding. This results in a lesser intermolecular distance between water molecules. Consequences and applications of this anomalous expansion of water. Number one, preservation of aquatic ecosystem. Anomalous expansion of water is important for sustaining aquatic life in cold regions or during winter. During cold weather, the top layer of a water body cools first. The temperature of the top layer drops to 4 degrees Celsius. The top layer then becomes denser than other layers, descends to the bottom of the water body. This process happens continuously to create a temperature gradient. The bottommost layer remains at 4 degrees Celsius. At this 4 degrees Celsius, aquatic life can thrive. The temperature gradually decreases as the depth decreases. The topmost layer is the coldest. Eventually, the top layer freezes, thereby forming an insulating blanket that prevents further freezing to some extent. If there was no anomalous expansion, the waterworks have frozen altogether. Ice fishing. Have you ever wondered how fish survive in cold winter weather, or where they go when lakes and ponds freeze over? Like many people, fish tend to be less active in the cold. As cold-blooded creatures, their metabolism dips when temperatures take a dive. The layer of ice that forms on top of a lake, pond, river, or stream provides some insulation that helps the water body retain its heat. Because warm water sinks in very cold freshwater, fish in these water bodies often gather in groups near the bottom. This is the reason why ice fishing is possible. When ice forms, it floats above warmer water, insulating it and letting fish live on through the winter. Beneath a thick sheet of ice may be thousands of fish. Those who ice fish experience a unique kind of fishing and often have a lot of success. The third consequence, bottle burst. If you put a fully filled water bottle in the refrigerator and its temperature is below 4 degrees Celsius, then according to the anomalous behavior of water, the water inside the bottle will expand. Therefore, due to no space in the bottle for the expansion of water molecules, water will exert force on the walls of the bottle and it will burst. Withering of rocks. Water seeps into the cracks and crevices of rocks. During winter, when the temperature falls below 4 degrees Celsius, the water expands, resulting in hydrostatic pressure on the rock. This produces cracks on the rocks and helps in weathering the rock. In rainy season, a lot of water sweeps through numerous cracks and fissures in rocks. In water season, when temperature falls below 4 degrees Celsius, going down to 0 degrees Celsius or below, expansion of water takes place, thus developing high pressure. This results in the breaking of the rocks. Another consequence of the anomalous expansion of water is pipeline leakage. Some water pipelines start to leak when the temperature falls below 4 degrees Celsius. This is due to the pressure created by the anomalous expansion of water. Changes of state of water. When a state of matter gains or loses heat, it undergoes a change. A gain in heat is called an endothermic change, while a loss in heat is called an exothermic change. Let us consider a block of ice which is in the solid state. The change from solid to liquid is called fusion or melting. To melt 1 gram of ice requires 80 calories. A calorie is defined as the amount of energy needed to raise 1 gram of water 1 degree Celsius. So in order to melt 1 gram of ice to liquid, we need 80 calories, and this is called the latent heat of fusion of ice. If we have m grams of ice, the amount of heat that is required to melt all of those grams of ice is given by the formula Q equals m times L sub F. The change from liquid to ice is called solidification or freezing. This process will release 80 calories per gram. The change from liquid to vapor or gas is called evaporation. This process requires 600 calories. So, 600 calories per gram is called the latent heat of vaporization of water. If you are given m grams of water, the formula to find the heat required to vaporize this water is given by this equation Q equals m times L sub V. The opposite of evaporation is called condensation. The latent heat of condensation will release 600 calories per gram of liquid water. Sublimation is the process of changing from a solid to vapor without passing through the liquid state. In this process of sublimation, we add thermal energy. Deposition is the process of changing from a vapor state to a solid state without passing through the liquid state. Again, in this process, we remove thermal energy. We have a graph of temperature versus heat added during the changes of state of water. The horizontal axis represents the heat added Q in calories, and the vertical axis represents the temperature in degrees Celsius. We identify the melting point at 0 degrees Celsius and the boiling point at 100 degrees Celsius. Supposing we are given a block of ice at minus 10 degrees Celsius, and we are going to find the total heat needed to bring this ice at minus 10 degrees Celsius to 110 degrees Celsius. So first, we need a heat in order to bring the ice from minus 10 degrees Celsius to 0 degrees Celsius using this formula Q sub 1 equals m times C times delta T of ice. In order to melt all ice, that is from 0 ice to 0 liquid, we need this amount of heat. That is given by Q sub 2 equals m times L sub F. This same amount of heat is removed if we want to bring liquid at zero to ice at zero. And that is the freezing process now. So, to bring the liquid at zero to liquid at 100 degrees Celsius, we need this heat Q sub 3 equals M times C times delta T of the liquid now. At 100 degrees Celsius, evaporation occurs. From 100 degrees Celsius liquid to 100 degrees Celsius gas, we need this amount of heat, which is given by Q sub 4 equals M times L sub V, where, where L sub V is the latent heat of vaporization of water. The same amount of heat is removed if we want to bring gas at 100 to liquid at 100 degrees Celsius, and the process is called condensation. Finally, when we bring gas from 100 degrees Celsius to 110 degrees Celsius, we need this amount of heat, Q sub 5, equals mc times delta T of gas. So, in order to compute the total amount of heat needed to bring ice at minus 10 degrees Celsius to gas at 110 degrees Celsius, we just add all of the heat added. So, Q total equals Q sub 1 plus Q sub 2 plus Q sub 3 plus Q sub 4 plus Q sub 5. Example number 1. Find the total amount of heat needed to change 10 grams of ice at minus 5 degrees Celsius to 110 degrees Celsius. Specific heats are, for ice, it is 0.50 calorie per gram per degree Celsius. For the liquid, it's 1.0 calorie per gram per degree Celsius. And for gas, it's 0.48 calorie per gram per degree Celsius. The latent heat of fusion of ice is 80 calories per gram, and the latent heat of vaporization of water equals 600 calories per gram. Solution. First, we identify the initial temperature, minus 5 degrees Celsius, and the melting point at 0 degrees Celsius, boiling point at 100 degrees Celsius, and our end temperature is 110 degrees Celsius. So first, from negative 5 to 0 degrees Celsius, the amount of heat needed is given by the formula Q sub 1 equals mc delta T of ice. Substituting the values, our mass is 10 grams times specific heat of ice is 0.5, and the change in temperature of ice is final minus initial 0 minus negative 5, simplifying Q sub 1 equals 25 calories. At 0 degrees Celsius, ice at 0 degrees Celsius to liquid at 0 degrees Celsius, we are now in the melting process, and in order to melt all ice, we need this amount of heat Q2, which is given by M times L sub F. And substituting the values, you have 10 times 80 equals 800 calories. From 0 to 100 degrees Celsius, this is now the liquid state. We compute the heat that should be added equals Q sub 3 is given by the formula Q sub 3 equals M times C times delta T. This time, this is now in the liquid state. So substituting the values, The mass is 10, the specific heat is 1, the change in temperature of the liquid is 100 minus 0 is 1000 calories. At 100 degrees Celsius, that is during evaporation, liquid at 100 to gas at 100, the heat that must be added is Q sub 4, which is M times L sub V equals 10 times 600 is our latent heat of vaporization of water. So 10 times 600 is 6,000 calories. Finally, from 100 degrees Celsius to 110 degrees Celsius, we need this amount of heat, Q sub 5, which is given by M times C times delta T of gas. So this is 10 times 0.48 times 110 minus 100 is 48 calories. Therefore, the total amount of heat needed equals Q sub 1 plus Q sub 2 plus Q sub 3 plus Q sub 4 plus Q sub 5. So substituting, we have 25 plus 800 plus 1,000 plus 6,000 plus 48 equals 7,873 calories. Example number 2. Find the total amount of heat needed to change 10 grams of ice at minus 5 degrees Celsius to gas at 100 degrees Celsius. Specific heats are given. C of ice is 0.5 calorie per gram per degree Celsius. C of the liquid is 1 gram calorie per gram per degree Celsius. C of gas is 0.48 calorie per gram per degree Celsius. The latent heat of fusion of ice is 80 calories per gram, and the latent heat of vaporization of water is 600 calories per gram. So, our initial temperature is negative 5 degrees Celsius, and the final temperature is 100 degrees Celsius. So, our graph will only have minus 5 degrees Celsius, 0 degrees Celsius, and 100 degrees Celsius. So, from negative 5 to 0 degrees Celsius, we need this amount of heat, Q sub 1, which is given by M times C times delta T of ice. Substituting the values, we need 25 calories of heat. From 0 to 0, in other words, ice at 0 to liquid at 0, during the melting process, we need this amount of heat Q sub 2, which is given by M times LF. So 10 times 80 equals 800 calories. To bring the liquid at 0 to liquid at 100, we need this amount of heat, which is given by Q sub 3 equals MC delta T of the liquid. So substituting, simplifying, we have Q sub 3 equals 1,000 calories. Since we are required up to the gas state for this problem, we continue at 100 degrees Celsius. We have the evaporation process now, and we need this amount of heat Q sub 4, which is given by the formula M times L sub V. So, substituting the values, we have 10 times 600 equals 6,000 calories. And to find the total amount of heat needed, we add all of these heats. We have Q sub 1 plus Q2 plus Q3 plus Q4 equals 7,825 calories. Example number 3. Find the total amount of heat needed to change 10 grams of ice at 0 to water at 5 degrees Celsius. So specific heats and the latent heat of fusion and vaporization are given. So in this problem, we are only required to find the amount of heat needed to change ice at 0 to water at 5 degrees Celsius. So the graph would look like this at 0 degree Celsius. That is the melting process now. And the heat added is equal to M times LF. Is 10 times 80 is 800 calories. So, from 0 to 5 degrees Celsius, we need this amount of heat, Q sub 2, given by M times C times delta T of the liquid. So, this is 10 times 1 times 5 minus 0 equals 50 calories. So, the total amount of heat needed is just Q1 plus Q2, which is 800 plus 50 equals 850 calories. Thanks for watching. Please do not forget to subscribe.